introduction to normal distributions and the standard normal distribution. So remember that we talked about different variables. We said that when we have variable in statistics, those variables are denoted by X. That variable can be a discrete or countable variable, or it can be continuous. Discrete, like the number of students sitting in this class, continuous, like time or volume. Well, last time we talked about discrete random variable, and we introduced one important discrete probability distribution, and then we talked about binomial distribution. Discrete probability distribution. Then we talked about a binomial distribution. Remember that X in a binomial distribution counts the number of successes in your experiment. So we're done with discrete variable. We're going to talk about continuous variable and normal distribution as one of the important continuous probability distribution. So when you have a continuous variable, the variable that takes on values in between two numbers, we talked about continuous probability distribution. Then after that, we're going to talk about a normal distribution. So let us take a look at the definition. A normal distribution is a continuous probability distribution for a random variable X. So we have a random variable, it is continuous, and we form a normal distribution. The graph of a normal distribution is called a normal curve. A normal distribution has the following properties. So remember that we have a collection of data. Those data are continuous variable. The collection of data has the following properties. First of all, the mean, median, and mode, they are all equal to each other. So the measure of center can be either mean, median, or mode. The normal curve is a bell-shaped graph, and it is symmetric about the measure of center, which can be mean, or median, or mode. Bell-shaped graph. These are just your bars, shows the frequency of your collection. And then we look at the behavior of the distribution. It's a bell-shaped graph. The total area under the normal curve is equal to 1 or 100%. The normal curve approaches but never touches x-axis. So as you can see, there's always a gap in between x, horizontal axis, and the tails of the graph. Between mu minus sigma and mu plus sigma, remember that mu was the mean of the population and sigma was the standard deviation of your population. The graph curves downward. So take a look at this. Mu minus sigma mu plus sigma, and here we have in between mu minus sigma, mu plus sigma. So between mu minus sigma and mu plus sigma, the curve has downward behavior. Before that and after mu plus sigma, the curve opens up. These 2 points are called inflection points for the graph. The x value is mu plus sigma, another x value, mu minus sigma, and these 2 points on the graph are called inflection points. So we have learned that a discrete probability distribution can be graphed using a histogram. Remember that it was like this. You had your x values, 0, 1, 2, 3, 4, and the rest stops at n. And then you had some bars. They are all attached together, no gaps in between, and you form your histogram. This is for discrete variable. For a continuous probability distribution, we can use probability density function, PDF. A probability density function has 2 requirements. First of all, the total area, so this is the area, the total area under the curve is always 1 or 100%, and 2, the function can never be negative. As you can see, the function is always above x-axis. It is always positive. A normal curve with mean mu and standard deviation sigma can be graphed using this crazy looking function. So this function says, hey, y or f of x is equal to 1 over sigma times square root of 2 pi e raised to minus x minus mu squared divided by 2 sigma squared. So instead of using this formula to find the probability, we're going to use our calculator. Example. Which normal curve has a greater mean? Recall that mean is a number on horizontal axis. Take a look at graph P. The mean of graph P, which is a number on horizontal axis, is 12. So mean of curve B is 12. The mean of curve A, see the different color, the mean of curve A, which is 15, of course, is greater than the mean of B. So which normal curve has a greater mean? A. Which normal curve has a greater standard deviation? So what's the meaning of that? It means that which one spreaded more? Greater standard deviation, it means that more spread. Well, take a look at your curve B. Your curve B spreaded along x-axis, and it is larger than the spread of curve A on x-axis. So as you can see, the spread in curve B is larger than the spread in curve A. So the answer is B. Standard deviation of B is greater than the standard deviation of A. So here's a question. We know that when we collect data, the data are in X values. How do we convert X values into Z values? We have a nice relation between X and Z. When we have X values, the original values, we can follow the formula Z equals to X minus mean divided by sigma. Note that we can round them to nearest 100. When you convert them into Z, you can use the Z table or your calculator to find the area. The standard normal distribution is a normal distribution with mean equal to 0 and standard deviation equals to 1. So the mean of the standard normal distribution is 0 and standard deviation is equal to 1. Take a look at previous page. In previous page, we have just a normal distribution. On the horizontal axis, when we are looking at the mean is just a number. It doesn't specify mean to be 0 or standard deviation to be 1. And note that the name is a normal distribution. When we are using Z, we call it a standard normal distribution. The mean is 0, so the center is 0, with standard deviation equals to 1. Again, the area is 100%. We have a bell-shaped symmetric graph, but the name of it is standard normal distribution. On the horizontal axis, instead of having X value, we have Z value. So what's the use of Z? Well, take a look at these examples. Question says, find the cumulative area that corresponds to a z-score of 1.15. So we are looking for the area corresponds to 1.15, and here we have z-score. We don't have the actual X value. It might be hidden, but we have our z-score and we can find the cumulative area or the probability. Take a look at the graph. Here you have your z. All z values are going to be on the horizontal axis. 0, 1, 2, 3. On the left-hand side, -1, -2, -3. And here we have our graph, bell-shaped graph. Okay, question says, hey, first locate 1.15. 1.15, suppose this 1.15 is here. And since we are looking for the area, cumulative area, it means that we need to shade this big portion below the graph on the left side of 1.15. To find this area, we're going to use our calculator. The area to the left of 1.15. To the left is important because if it says, hey, to the right, we have to enter different values in our calculator. So to use the calculator to find the area to the left, turn on your calculator. Second, bars. Now you need to click on normal CDF. The cumulative area is going to be normal CDF. So when we click on normal CDF, since we are finding the area to the left of 1.15, the number on the left-hand side is going to be very small, -1, e, this is the exponent, 99. So it's a very small number on the left-hand side. So note that we are finding this area between these two numbers. You don't know what number is located on the left-hand side. So instead of writing an exact number, you can use -1,000 or -10,000 or -1 E99. And the number on the right-hand side where you stop is 1.50. So your lower bound, lower limit, if you don't see this number, you can use -1,000. Your upper is going to be 1.15. So between these two numbers, 1.15, the mean of the standard normal distribution is 0 and standard deviation is equal to 1. So paste, and we have 0.84, 87, 49, and so on. The probability or the area is going to be roughly 0.875 or 87.5%. Remember that the total area is 100%. This portion, this red portion, is 87.5%. Let us take a look at another example. 2 says, find the cumulative area that corresponds to z-score -0.24. Okay, let us take a look at our graph. This is our graph. Again, we have z values on the horizontal axis, 0, 1, 2, 3. On the left-hand side of 0, we have negative numbers. And here we have our graph, which is like this. Okay. Now it says, hey, find the cumulative area corresponds to z-score negative 0.24. Negative 0.24 is going to be a small number, which is here. Negative 0.24. This is on the horizontal axis. This number is a number belongs to horizontal axis. If we want to find the area corresponds to this number, it means that we're looking for this portion, this region below the graph. What is this area? What is this probability? The total area below the curve is 100% or 1. So by looking at the curve, you say, hey, it's roughly less than 50%. But how do we find this area? Again, we're going to use our calculator. The area to the left of negative 0.24. Let's take a look at our calculator and enter the instruction. So here, let's clear this. We go to second, vars. So second, then vars, and then here we go to normal CDF. Normal CDF. Okay, normal CDF, we need to have a lower bound and also upper bound. What is the lower bound? Take a look at your graph. We're looking for the area between these two numbers. I know the upper number is negative 0.24, but what is the lower number? What is this number here? You don't have the exact number. So you either use negative 1E99, or you can use negative 1,000, a very small number. So this is our lower bound, negative 1E99, or if you don't have that, you can use negative 1,000. And the upper bound, well, where does it stop? It stops on the horizontal axis. It stops at negative 0.24. What is the mean? So here we have negative 0.24. Just don't forget to plug that in. The mean is 0 and standard deviation is 1. Base. And here we have this area, this red region below the graph between these two z values. So this area, or the probability, as we, before doing any calculation, looked at it at the beginning of solving this question, the total area is 100%. It is less than half of this area, so less than 50%. And as we calculated that, we have 40.5%. So this probability is 0.45 or 40.5%.
Hello?